Hello everyone, myself Gitanjali Nikam. Today I will solve my first internal question paper of set A. Question number 1 is find the cube root of 12 using Newton-Raphson method. Correct up to 4 places of decimal. From this question we can see that the equation is x cube minus 12 is equals to 0. Hence fx is equals to x cube minus 12 and f dash x is equals to 3x square, which is the differentiation of that equation. Now we know that the Newton-Raphson's formula xi plus 1 is equals to xi minus f of xi upon f dash of xi. Now, from from this formula, we need to find the value of xi, and we find the value of xi as putting the value of x is equals to 0, 1, 2, 3 in the equation of fx. Then we get different values at different points. At 2 we get the value minus 4, and at 1, 3 we get the value of fx is 15. So we can say that our root is lies between these points, but it is not very close to the 0. Hence we put the value of xi is equals to 2.5. Then we get the value of fx is equals to minus 3 point something. Then so we can say that f of 2.5 is equals to 3 point something, that is very close to the 0 as compared to other values. Then we consider the value of x0 is equals to 2.5. Then we put the value of x0 2.5 in the equation in the Newton-Raphson's formula. Then we get the value of x1 as 2.3067, and in the second iteration we put the value of x1 is equals to 2.3067 in the Newton-Raphson method. Then we get the value of x2 2.2894. Iteration I is equals to 2. We put the value of x2 2.2894 and get the value of x3, which is equals to 2.2894. That is at the second iteration and the third iteration we get the same values of x. Then we say that the cube root of 12 is 2.2894. This is the final root of that question. Question number 2 is write an algorithm for successive approximation method. Now in step 1 we read the value of x0, e and n. x0 is the initial guess, e is the allowed error in the root, and n is the total iteration to be allowed for convergence. And in the second step we initialize the value of x1 as g of x0, and in the step third we initialize I is equals to 1 and iterate a loop till n in steps of 1 do. In the fourth step, we initialize the value of x0 as x1, and in the fifth step, we initialize the value of x1 as g of x0. If x1 minus x0 divided by x1 is less than error, then we go to the ninth step. And ninth step is write converges a root I x1. Or if this condition is not satisfied, then we and the fourth and write does not convergence a root x0 and x1.